Hey class, it's Bill here with an on-demand video on returning multiple values. This is supplemental material for week 3. It's not in your book. I don't think it's anywhere in your book, but since this project that we're working on has an element of it that would make this kind of useful, and because we're opening the door to objects very soon anyway, this is a topic that I think your brains are ready for, so let's talk about it, and if you wish to use it in this project, that's great. If you don't, fine. You'll understand a little bit more of the basic stuff of why this works very soon as we get into object-oriented programming. Anyway, so far all of our functions have returned only a single value. That's all we know how to do, and that's all that's easy to do in a language like C or Java. It's not hard in language like Python, but Python does a lot of magic for you. No magic here. So most of the time that's fine. A lot of times a function returns one thing and that's okay. But sometimes we just need more than that. Now, in some languages, in the C-based languages, we have things called a structure or a struct. And a structure is like a collection of potentially different types of data that kind of is packaged together as one thing. That's what we want here. We want the structure so that we can sort of fill it in and then pass the structure back because the structure then is the one thing we're passing back, and then it would be fine. We don't have that in Java, but we can do something like it with a simple object. The object is not going to be a full-fledged, fully fleshed out object that we will be using in our projects later, but we can provide a bare bones thing to make it work like a struct. So let's look at how we can do this and open the door to objects just a little tiny bit. Some of the syntax here will look odd until you get into a little more objects, but actually, you know, you've started using objects, so you won't find it, I don't think, all that odd. So let's take a quick look at a simple program. And has a main program that doesn't do a heck of a lot. It has a function called integer multiply, and it takes two integers and then it multiplies them together and returns them. Now, I've used more lines than you probably want to use here, but there's a reason for it, and we're going to see that in just a moment. You see that main up here takes the result in. It creates an integer to store that result. It stores it and then prints it out. Again, I've used more lines than you would normally use. You could put all this stuff in one line, but anyway, I've done it for a purpose, and you'll see why in just a moment. So the first thing that we need to do is let's look at this, and let's say that we look at this function and we say, you know, we're going to do something really similar. We're going to multiply, divide, add, and subtract. We could do all of those as separate ones, and that may be the right thing in this case, but let's say, just for argument's sake, that you wanted to have something called int math. And int math would, instead of returning just one thing, it would do all of those different math operations and return them as one little package so that you could unpack them and use them on the other end. So if you want to do that, then you need to learn this new topic, and the new topic looks like this. First, we need to create a new class. We are creating a class, and that class is going to be our object that we're going to use to put this information in, and we're going to pass back that object. And I'm just going to call it int math return, for lack of a better name. It is a class, so we're going to do int math return and say a class, and we're going to say OK. Now in that, let's open that up, and then let's get rid of all of this stuff. Again, please do normal Java doc stuff, but I don't have, I'm not going to bother with that for just a moment, so let us do this. Okay, so we start with an empty class, and we're going to create now a very, very simple object. In fact, we're going to do things that we would not do in an object, so I'm going to put a note. Do not do this when you create objects, right? We're specifically doing things that we do not want to do, and that's probably why the book doesn't want you to know about this, because with normal objects you don't do this stuff. And the stuff that you don't do is you start with the word public. The whole concept of objects is encapsulation, and that means that the object protects itself from the outside world, and the object tends to not want to give access for people to poke in and just push in data arbitrarily into the object. So typically you don't want to do something like this, but we want to do it specifically for this reason. So I'm going to create some little fields, and they're called fields because they are public, and I'm going to create these for, let's see, divide, add, subtract. And I'm going to leave my object just like that. Do not do this, and I'm going to say public. when you create objects. So we're going to have a super simple object. Why is it simple? Well, number one, it uses fields. Right? So normal with objects, we don't use public, we use private, and we protect that data. The other thing is that this object has no behaviors. Normally you want objects to have both data, that is state, and behaviors. So you want the object to be able to do things. But in this case, we don't want the object to do anything, and we don't really care about protecting this data. In fact, our whole point is to expose this data so the outside world can use it very easily. So that's all we need to do here is provide these little fields that we can poke things into from the outside, and then we can get them out on the other end. So that is our int math return. We'll see it compiles. There's really nothing too exciting here. And then I'm going to put that out of the way for the moment. Now I'm going to come back to main, and we're going to modify these functions. So take a screenshot if you want. Pause and take a screenshot right now and look how we morph this into something new. In fact, yeah, I'm going to I'll just insert it here and we'll do this new thing. So we're going to create, notice I'm using private. The only reason I'm using private in this main class is because I don't want it exposed when I go to do run from the project explorer, right? I don't want to see this in the list. I'm fine with just seeing main. So I'm going to say private, and of course it's static. We haven't done anything other than static. And I'm going to now need to say, what is the return type of the thing I'm going to give back from this function? And it turns out that is going to be an int math return. It is going to be an object of that type. And I'm going to then name this, which is going to be int math, and I'm still going to take in int first int and int second int. Right? And then I'm going to write my code. Now, the code is going to look a lot like the code below, except we've got to do something new. So I'm still going to need to create an object to store the result. And the way that you create these, you've seen this in some of your code using objects, so this isn't too exciting, too earth-shattering, is I'm going to say I need to create an int math return type. I'm going to call it my math return, just like below. And then I need to create a new object in order to use that object. So I say new int math return. All right, so this is object notation. I am creating a reference to an object called a math return, and that reference is pointing to an actually real instantiated int math return object. Right? So now, here's the magic. Not only can I just talk about math return, because math return is now a class, but inside it, because we made these fields, I can refer to a sub-piece like this. Right? I can say math return dot multiply, because I'm discussing a field. I'm drilling into one field, is equal to, set equal to, assigned to, second int. Right? So I'm filling in this field of that object by doing that multiplication. And likewise, I will do the rest. So you see now I've filled in the rest of these. I'm filling in all of the fields by simply using the dot notation on the object, and I am filling in the data, right? The field with the data that I want. So that makes perfect sense. Now, we can't forget to return the thing, right? In the end, just like we used to return the integer variable, here we're going to return math return. It just so happens that math return is a type of object of that type. So we've packaged it up, we've put it in an object, and we are returning that object as a return from the function. Makes sense? If you compare it now, stop and pause, compare it to this, you'll see it's not all that different. So now we need to come up to main, and we need to do a little bit different thing up here. What do? Well, we're still going to take a result in, but now it's an int math return, right? That's the type of it, and we're still going to call it result. Now, notice we don't have to create a new object up here because we don't need to. We don't need to create it here. We've created it here, and we'll return it. We just need a reference to be able to receive it, which is something we know happens with objects. So now we're going to still call it the exact same way, right? This line looks just the same, but now instead of result, I can start unpacking that by saying, hey, I want to get the result, but the result is an object, so I want to drill in to the different pieces. So I can come here and I can fill all of these out, and I'm simply going to change add to subtract, and I'm going to fill in the rest of the fields in the drill downs over here, right? So instead of that, I'm going to do this, and so forth. So now I have filled in all of these, and I can line them up if I am so inclined, which I am. And so now I have, on this side, I have created the object and I have filled in its fields with all the different operations. I've returned that reference to that object in memory. And then on this side, I can receive that reference to an object, which is declared here, and I can unpack it by looking into its fields, drilling down into its fields with the dot notation. So this is how you would represent, how you would do these operations and return multiple values. So let's see what else. Of course, I don't want to call int mult. I want to call int math now, right? I'm going to compile it. Seems to work. Let's see if we can run it successfully. And you'll notice up here, of course, we show here that main uses, or main has an int math return. So it uses that class. Let's run it and let's see if we get all the magic that we expect to have happen. And here's our terminal window. And in fact, yes, there is all of our integer math. So that is just a quick look at how you not only create a very simple class that acts as a struct, right? This is a behaviorless field-based object, which is like a struct in C. And then in main, how we used it, and we walk through how to create the thing, put in data into its fields, send the result back, and then grab the data out of the fields on the other end. So that gives you a quick idea of how that would work, and you're welcome to use that in your projects if you like. And you'll be getting into objects, so we will do a lot more later, but as I said, don't type public very much when you're in objects. You need to think about public and private a lot more specifically when you're in that world. It's going to be a lot of private and not much public in that world. So thanks for watching this video. Let me know if you have other questions, and look forward to hearing your comments and talking to you in the forums and online about it.